we're going to look at what physics is, because that's the subject matter of today. And here you have Aristotle. He defined physics. Okay, he's the first guy to define the word physics. We don't know if Aristotle really, he existed, but the question is whether he wrote all the stuff that we have today. It looks like it came from his school. You have to remember, Aristotle was from the north, and he was the tutor of Alexander of Macedon. Okay, so everybody in Athens, where he lived for a while, did not like him very much, because he was kind of like a spy for the first for the Philip's court, and then for Alexander's court. And they were enemies, and Alexander was powerful, and so on and so forth. In fact, after they overthrew a government over there, after Alexander died, Aristotle had to go back north to Macedon, because they were probably going to execute him. Anyways, he defined the word physics, and this is his notion of physics. Here it is, very briefly. If I can get it here. Okay, he said, deals with the most general philosophical principles. That's what physics is, philosophical. Physical theories in the modern sense, they say, but we don't have physical theories today. We only have mathematical theories. There's not a single physical theory coming out of mathematical physics. The physics part is too much. It's just, not needed at all. They don't do physics at all. They do mathematics, yeah, but they don't do physics. And they have no physical explanation. So I don't know why they say that Aristotle did philosophy rather than physical theories. That's bunk, complete bunk. We don't have physical theories today from the mathematical establishment. Here we do have physical theories, but not from the mathematical establishment. And principles and causes, and not merely to describe. Yeah, because what they do today is describe, because that's all that math can do. Describe. You cannot explain with math, with an equation. Okay, you can't do that. And I guess they don't understand that, and they keep trying to look for the famous equation, maybe the grand unified theory, the theory of everything, or one of those, who knows what. They're doing math, and they think that because they have an equation, they're going to be able to explain how this universe works. And it turns out they can't, and they never will, because math is the wrong tool to use to discern, how this universe works. So they've got the wrong tools. We have the wrong people in charge of so-called physics. They're mathematical physics. They're mathematicians. They have absolutely nothing to do with physics. It's mathematics, and the mathematics is irrational. Okay, and so what happened after Aristotle? We can go forward up to the 17th century, and they started doing a different type of so-called physics. They called it natural philosophy, which has nothing to do with philosophy at all. It's got to do with physics. They were trying to explain phenomena, but what's the issue? They introduced, math was already there pretty much, but I guess they harped more on math. They started building the calculus and some other math there, but more important, they started using experiments to verify, to prove. And that's where we entered a no man's land. Here we entered into big trouble. And one guy that synthesizes that was Galileo, early on in the 17th century. He said the following. He said, philosophy, referring to natural philosophy, right? What was really known as physics today, is written in that great book which ever is before our eyes, the universe. But we cannot understand it if we do not first learn the language and grasp the symbols in which it is written. The book is written in mathematical language. Then he says mathematics is the language in which God has written the universe. But that was the first half, and that was pretty much in line with Plato and Pythagoras and some of these other fellows in the Greek world. But then he continues, he says, I think that in the discussion of natural problems, we ought to begin not with the scriptures, but with experiments and demonstrations. Now, we don't use experiments and demonstrations in science. And you say, Bill, you're crazy. What do you mean? Of course we do experiments in science. No, we don't. Okay? Now, I was an engineer for many years in the semiconductor industry, and people say, Bill, so you did a lot of engineering. Yeah, we did engineering, but people don't really know what engineering and science is about. They think that a technician is an engineer. They think that a technician, guy who works with his hands, the guy like Tesla, for example, Nikola Tesla, he was not an engineer. He was not a scientist. He was a technician. He was an operator. He's a guy who worked with his hands, had a little knack for seeing certain things, and he came up with ideas and so on. But Tesla never understood how this universe works any more than his nemesis after a while, which was Thomas Edison. They never understood what electricity is. They never understood any of that. They didn't know what an electron was. Okay, so all these people, they talked a lot, they bragged a lot, like Tesla did, but he knew nothing. He was just a technician, a little operator that worked with his hands. An engineer does not work with his hands. A scientist does not work with his hands. Okay, scientist is the guy who's in his office. He's got a girl on his left hand for enthusiasm, for raising his spirits. He's got a beer on the other hand, and he puts two fingers here at the top of his head, and he thinks. His job is to think, to make sense of the information that comes from the lab. The guy who goes to the lab is either a technician, which is a specialized operator. People say, Bill, you work down the line? Yeah, I work with big machines, accelerators and so on, right? And operators who are there working every day, they knew how to run the machine better than me, hopefully. They worked every day on the machine. It's like an electrician. Maybe the engineer or the scientist, he designs something, but the person who's got to work with it, the technician, the electrician, he knows how to run that stuff much better than the guy at the office. No doubt about it. So, these people knew how to run the machine better than me. They had better because they ran it every day. And I had to write the specs, for how to run the machine. I had to train trainers, but obviously these people knew a lot more about how the nicks and crannies of the machine. They have to. And that's what a technician is, a guy who works with his hands. Engineer, scientist, they don't get their hands dirty. They never use their hands. In fact, you can chop them off completely. Scientist is a guy who works with his head. Okay? That's what it is. And same with an engineer. We don't use our hands. It's demeaning to use our hands. Okay, and how about we have math? Do we use math in science? Well, here you have a fellow. His name is Isaac Newton. And he said, we have to explain the phenomena of the heavens and of our seas and the power of gravity, etc., etc. And then he says, hitherto, I have not been able to discover the cause of those properties of gravity from phenomena. And I, framed no hypothesis. He had no theory. He had no explanation for how the universe works, how gravity works. And it's interesting what he says next. He says, for whatever is not deduced from phenomena is to be called an hypothesis and hypothesis, whether metaphysical or physical, whether occult qualities or mechanical, have no place in experimental philosophy, meaning in physics. So he's saying that, if you've got a theory, that's got nothing to do with physics. What they're going to do is math. And there you have math. You have an equation, his famous equation, gravitational constant G, mass divided by the distance squared, that's equal to force. And that's all that is a description. There's no explanation there. You cannot get an explanation from an equation. And so this is the big problem we have today. We have a lot of equations, no explanation. We have descriptions. That's all that math can do. And people don't always understand that. They say, all these mathematicians, they're so smart because they studied 10 years. They know all these equations. Yeah, they know the equations, but not one of them can tell you how this universe works. Because for that, you need a physicist. A physicist doesn't work with equations. Physicists work with objects, with things. You have to explain a mechanism, a cause. Then you understand how this universe works. Okay, and then we have observation. Is observation part of science? And that's a big one because a lot of people say, how can you do something without observing? How can you explain something if you have not observed it? They come with these irrational questions, okay? And all I can say is the following. Here's a fellow, and he criticizes that, and he says the following. See if I can put him up here. He says the following. He says, Gaede's theory is not compatible with what? Modern observations. Okay, so my theory is not in line with him. Okay, I'm sorry to hear that. Observations does not only refer to our eyes. We can also detect with instruments. Okay, so we can touch, see, and hear at the atomic level. Or we can, or the machine. We can't see individual electrons yet, right? Hence, the need to continue with what? Novel ideas, observation, and experimentation until we eventually discover the actual mechanisms involved. This is what people believe in. And what's the problem with all that? Well, the problem is that you cannot observe, like, eyes. You want to use a machine? Hey, go ahead, use the machine. Can the machine detect the invisible and intangible? I mean, I dare you to get the machine that detects the invisible intangible. What machine are you going to make? The machine hopefully has to receive some signal or touch in some way or whatever. And if it's intangible and invisible, what's the machine going to tell you? But they don't understand that. I mean, you have the mediator of light and gravity, and it's completely intangible, invisible. What experiment are you going to run? All you can do is do what the engineer, what the scientists do. They stand in their office with a girl with a beer, and they visualize. They try to imagine how this universe might work. Okay? They come up with theories. One guy has theory A, the other guy has theory B. Fine. But I mean, you have to try to visualize how this universe works, because there's no experiment you can run to detect gravity or light, the mediators, right? And no machine can do that either. So I don't know what this fellow's trying to do with his brain, if you can call it that. I mean, he was chipped, obviously. Probably got the scarecrows. Right? Okay, so just one more thing here on experiment. What are experiments for? Well, Faraday used to do experiments, and what did he try to do? He was just wowing people. He was saying, hey, look at this. A magnet attracts another one. And look at the electricity here. But Faraday could not explain a single experiment that he did. He just showed them, like, wow, them. It was a show, but he wasn't able to explain a single thing. He died without understanding anything. Experiments can be used as a learning tool. You're in your dark basement, okay? And so you do Frankenstein or whatever you want to do in your dark basement, that's fine. But when you come to the conference, we want an explanation. We want you to tell us how, why, what caused it to be like that. That's when you shine. That's when you become a physicist. And then, but what's the problem with experiments today? Well, the mathematical establishment uses them as evidence. Okay, they bring evidence. They say, here's the evidence for whatever experiment you run. And what's that used for? That's used for to persuade, to convince people, to convert them, to recruit them. The only purpose of evidence is what the prosecutor does. He uses it to persuade the jury. And so, no, we don't have any use for experiments in science. We don't do experiments. We explain experiments. Okay, so let's get that right. We don't do experiments, hands. We don't do that. Eyes, we don't do that. We don't use our hands or our eyes. What we do is explain what caused the experiment to happen. You have the red liquid and the blue liquid. You mix them, kaboom, you have an explosion. You say, hey, every time you mix the red with the blue, it goes kaboom. And you can even say you need 3/4 of this and 1/4 of that for the kaboom to happen. Great, you have a mathematical description. Why does it explode? That's what we want to understand. And as long as you say, look, let me show you the experiment. Look, here it is. You didn't understand anything. All you know is that if you mix the red with the blue, it explodes. That's all you know. And you cannot explain why. We need the cause. Why? Why does that happen? And that's where all these people fail. They don't have a why, a cause. And because mathematical physics is not designed, especially mathematics, designed to tell us how this universe works. We have the wrong people in charge of that. Okay, and so what do we do with observation? With people who say, hey, you need to observe, because they introduce it as testimony. They say, let me give you an example. They say, for example, right? You go there and you observe something, right? And you say, I observed these particles colliding. Happenings every day at CERN, at the Large Hadron Collider, right? They say, we observed particles colliding. Well, did you observe particles? And they say, well, we can't see particles, but what else could it be? So they make an assumption and they introduce it as an observation. And what the common man understands for observation is that you use your eyes, that you saw it with your eyes. So they say, well, okay, if they saw it with their eyes, the two particles collide, who's going to question that? And that's not what the word observation stands for. The word observation is an assumption. They're making an assumption that we have particles, discrete particles, and these are coming together, colliding, and smashing one against the other. They're assuming that they're dealing with particles. That's an assumption. It's not an observation, but they call it an observation. We observed particles collide, and they put it in those terms. And so, what they're doing is testifying. They're already giving you their theory and asking you to believe it, or forcing you to believe it. And so what do we do in science? Well, we do it the mafia way. That's the way we like to do it. Okay, and we do it this way. Do it the Al Capone way. Observation is equal to testimony, witness, and we kill the witness. We make sure the witness never gets to testify. Okay, so we like to do it the mafia way in science. We get rid of the witness. We're not allowed to introduce testimony, which is what these people are doing when they say, we observed the particles collide. That's the problem. And predictions, do we do predictions in science? Well, the problem with predictions is they predict the past. I like to, if I go to an astrologer, and I recommend this for you as well, go to an astrologer and ask them, okay, you're an astrologer, you can read the future, you can tell me what's going to happen tomorrow, if I'm going to win the lottery, all that kind of stuff. Good. Before I pay you, I want you to predict the day I was born, and the name of my mother, and who was my grandfather, or whatever, right? If you can predict the past, for sure you can predict the future. If you cannot predict the past, then we have a problem with the future. If he doesn't know what already happened, I don't know what he can tell me about what hasn't happened. And that's the problem with mathematical physics. What they do, they have this. This is from the AI, if you look it up on Google. And you can see all these predictions. Look at how they use the word. The Big Bang Theory predicts, okay? Big Bang Theory is when the world exploded, how it came into being, that the early universe was extremely hot, dense, and small, and that it expanded and cooled over time. So it predicts the past. Hey, that's great. Cosmic wave, microwave background, the Big Bang Theory predicts that the universe left behind radiation after its hot, dense state. And they use the word left, past tense, left behind, okay? Abundance of light elements, the Big Bang Theory predicts that the universe would produce specific ratios of hydrogen, blah, 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 elements during the first few minutes. Okay, so 12 billion years ago, we can predict that in the first few minutes, this is what happened. Okay, they're all predicting all the past tense. Okay, they're all predict. I like the last one, slow time. The Big Bang Theory predicts that time would have run slowly in the early universe as Einstein predicted. All these people end up predicting the past. And so, we have a problem because they're using this language and it's irrational language, and people don't realize that these people are using this irrational language. They're saying, well, they're mathematicians. They know what they're saying because they studied 10 years of math and blah, 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 blah. And it turns out these people have an irrational language. They cannot tell you something straightforward how this universe works.